Hi, today we are looking at section 4.6 part 2. We're going to be talking about Descartes' Rule of Signs. René Descartes was a famous philosopher and mathematician. He was on this earth from 1596 to 1650, so only lived to be 54 years old, but he has a lot of major contributions in those areas of philosophy and mathematics. So one of the things that we're going to be looking at today, one of his contributions, is his rule of signs when it comes to polynomial functions. So if we have some polynomial function in descending order like this, the reason I know this is descending order is because this is n might be 5, this would be 4, 3, 2, 1 to the first power, and then a constant. So we're saying that we have this polynomial function with real coefficients. That just means we don't have any imaginary coefficients. They're real numbers like 5, 6, 10, a million, whatever. So the number of positive real zeros of the function is equal to the number of changes in sign of the coefficients of f of x, or is less than this by an even number. That even number is very important. The number of negative real zeros of the function is equal to the number of changes in signs of the coefficients of f of negative x. So that means we're going to have to plug in negative x, and then we're going to look and see how many changes in signs we have, or it's less than this by an even number. Once again, that even number is going to be important. So before we start looking at that pattern, I want us to think about whether or not these are going to be positive real, negative real, or imaginary solutions, because that's what this is going to be telling us about, whether we have a real zero or an imaginary zero. So this first one, negative 3 plus 2i, well, of course, that's going to be an imaginary, has an I in it. Negative 5, of course, that's going to be a negative real number. 5 is just a real number. Radical 3, sometimes people say, oh, that's not a real number. Well, yeah, it is. Radical 3 is just, it's irrational, but it's still going to be real. So it's a special type of real number. It's irrational, but it's still going to be a positive real number. I, of course, is imaginary. That's our most basic imaginary unit. And then what about negative 2 plus radical 10? Is that going to be a positive real or a negative real or an imaginary? Well, it's certainly not imaginary because it doesn't have a negative under the radical, and it also doesn't have an I in it. So therefore, it has to be either positive real or negative real. So I have to think, what's radical 10? Well, I know radical 9 is 3, so this is a little bigger than 3. So if I have negative 2 plus something a little bigger than 3, it's going to be positive real. So that's what we're looking for, is we want to have some idea of what kind of solutions we're going to have. So looking at this first one, this is my function, and I have, this is a negative to a positive. That's one sign change. Then I go from a positive to a positive. That is not a sign change because they're both positive coefficients. So I had one sign change. So what that means is I can have one positive real solution. Look back again. Or I can have less than this by an even number. So that means I could subtract 2, I could subtract 4, but I can't subtract 2 because I can't have a negative 1 as the number of positive real solutions I'm going to have. So that doesn't make any sense. I have to have one positive real. Now, let's go ahead and let's see what is g of negative x. That means wherever I have an x, I'm going to plug in a negative x. You see what I'm doing here? Here's an x. I keep that negative, but I had to plug in a negative x for this x. I have this x. I keep the positive 5, but I had to plug in a negative x. So g of negative x then, I always do exponents first. So a negative to the third power is going to be negative, but times this negative is going to make it a positive. A negative x squared, that's going to be a positive times that positive is positive. And then I have plus 12. So what that looks like then is I don't have any sign changes. So I'm going to have 0 negative real solutions. Now, something you have to think about is this exponent here. This highest exponent, or in other words, the degree of the polynomial, that tells us how many total solutions we must have. We must have 3 total solutions. Okay? So what that means is I'm going to have 1 positive real, 0 negative reals. So what do I have to have? Well, I would have to have 2 imaginary solutions. Okay, I'm going to put this in a chart for us. So we can have positive reals, we can have negative reals, or we can have imaginary. So for this case, I can only have 1 positive real, 0 negative reals, 2 imaginary solutions. Now, let me show you what this would look like on the calculator, this function. So if I put this in negative x raised to the third plus 5x squared plus 12. So a real solution is going to be wherever this crosses the x-axis. Okay, that's going to be my 0. Can you see how I only have like around, what is that? 1, 2, 3, 4, 5 point something. That's my answer for my 0, 5 point something. So that's a positive real solution. I don't have any negative solutions down here, and the other 2 solutions are imaginary. That's what we're talking about here. And it's a really cool rule to understand because it kind of allows us to narrow down what the graph could look like. All right, let's look at the next one now. I'm going to go ahead, I'm going to do g of negative x first. So if I do a negative to the 5th, is that negative or positive? That's negative. If I do a negative to the 4th, that's positive, times positive 4 is positive. A negative cubed is negative, but times that negative 4 would be positive. A negative squared is positive, times negative 3. A negative times a positive is negative, and that just stays the way it is. All right, so I look at this one, g of x, that's going to tell me how many positive reals I can have. So for positive reals, look at the sign changes. Positive here, this is a positive, that's nothing. That's not a sign change. Positive to negative, that's 1 sign change. Negative to negative, that's nothing. That's not a sign change. Negative to positive, that is, there's another one. And then positive to negative, there's another one. So I have 1, 2, 3 times where I had sign changes on g of x. But Descartes' rule of signs says I can have this or less than this by an even number. Well, less than this by an even number, 2 is even, so I can take away 2. So I can either have 3 positive reals or I could have 1 positive real. Okay, what about negative reals? Okay, look at the sign changes. Negative to positive, that's 1. Positive to positive is not. Positive to negative, there's another 1. Negative to negative, that's not. Negative to negative, that's not. So I had 1, 2 times where my coefficient signs changed. So Descartes says I'm going to have, it's equal to the number of sign changes for negative real zeros, or less than this by an even number. Well, I can take away 2, so I could have 0 negative reals. All right, let's put this in a chart now. Makes it easier to understand all the possibilities. We have positive reals, negative reals, and imaginary. So I can have 3 positive reals. I can have 2 negative reals. I have to have 5 total solutions. Well, 3 and 2 is 5, so that would mean 0 of them are imaginary. But I could also have 3 positive reals and 0 negative reals. Well, I have to have 5 solutions, so what do I have to have? 2 imaginaries. Okay? I can also have only 1 positive real, and I could have 2 negative reals. How many imaginary then? Well, I have to have 5 total, so 2, right? The last case is I could have, no, not last yet. Well, this will be last. Though I could have 1 positive real, I could have 0 negative reals, and how many imaginary reals? I could have 4 imaginaries. Zeros. I think I said real. Imaginary zeros, not imaginary reals. All right, so these would be all the possibilities. 3, 2, 0, 3, 0, 2, 1, 2, 2, or 1, 0, 4. I have to have 1 positive real solution. So if I were going to try numbers to see whether or not it's a 0, it makes sense to check a positive number rather than a negative, right? Because I might have none of those. So that's the reason why we use this. All right, let's try some problems here. Determine the possible numbers of positive real zeros, negative real zeros, and imaginary zeros, then solve. Okay, is this the same as the one we just did? Nope. All right, so I'm going to go ahead and do h of negative x first. So negative to the fifth is a negative. Negative cubed is negative times a positive is negative. Negative squared is positive times a negative. A negative times a negative is a positive. And that's negative. All right, so let's look at sign changes on the positive reals. So I go back to my positive x, h of x rather. Let's see, positive to positive, nope. Positive to negative, there's one. Negative to negative, nope. Negative to negative, nope. So I only had one. So I have to have one positive real. Okay, what about my negative reals? Negative to negative, nope, nope. There's one. Positive to negative, there's one. So I can have two negative reals, or how many others? 0, right? Because this has to go down by an even number. 2, 4, 6. But once I get to 0, it doesn't make sense to go any further because I can't have a negative number of something. All right. Now, this says we can use a graphing calculator to get started. Well, before we do that, though, let's make our chart. So we've got our positive reals, our negative reals, and our imaginary. We can have one positive real. I can have two negative reals. How many total? 5. So I'd have to have two imaginary then to get 5 total. I have to have one positive real. I can have 0 negative reals. And that would mean I have to have 4 imaginary. I know I have to have a positive real solution. Now, we could go back and think about, like, what are all the possible positive reals? Like, remember how we did this before? I could have plus or minus all these factors, 1, 2, 4, and 8, divided by all these factors, plus or minus 1. So I know that I can have all these different solutions of plus or minus 1, 2, 4, 8. When I mean solutions, I mean if we put in 0 there for h of x. So those are some possibilities. Now, it says we're allowed to use a graphing calculator to get started. I could use synthetic division on this and do it that way, but let's go ahead and take a look. Since it says we're allowed to, that's very nice. We're looking at our original function. That's what we're trying to graph or figure out zeros for right now. Not graph yet. That's coming up later. Okay, zoom 6. I should see one positive real in there because I have to have a positive real. Oh, there's negative ones too. Okay, look, it looks like it's at 2, right? I can check that by looking at my table, and yep, 2 is a 0. See it right there? That's awesome because that means that, and see how that was one of our possibilities, plus or minus all of this? Should be writing that. So 2, I'm going to use my synthetic 1. I have to use a placeholder of 0 for x to the 4th. 1, negative 2, negative 12, negative 8. I know I got to get a 0 here because I just found out it's a 0. Bring this down, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. And I'm left with this, okay? Now, what this would be, this is my remainder of 0. That means, yes, it went in evenly. Yes, it is a 0. But this is going to be x to the 4th, x to the 3rd, x to the 2nd, x, and my constant. That's going to be very challenging to factor, right? So I'm going to use my calculator. It said I can use it to get started. I'm just trying to find all the zeros. Negative 1 is also a 0. So I'm now going to put negative 1 not into my original, but into this, okay? Because I already know that if I factor out an x minus 2, this is what would be left. So I'm going to do the negative 1 into this, because remember how this is x to the 4th, x to the 3rd, x to the 2nd, x, and my constant. All right, so we've used this now. You don't need all that. I'm just explaining. So that's 1, 2, 5, 8, and 4. So I bring this down. This is 1, negative 1, add, negative 1, add, negative 4, add, negative 4, add. Okay, great. So I'm keeping a list here of all of my zeros. My zeros are, so far, 2 and negative 1. Okay, how many do I need? 5. I've got 2 out of 5. Not too bad. This, I can see, I can factor this. Look, this is my constant. This is my x squared. This is my x cubed. This is my constant. This is my x. This is my x squared. And this is my x cubed. Okay, so I've got what I have left after I take out these two is x cubed plus 1x squared plus 4x plus 4. That's what I'm left with after I take out a factor of x minus 2 and I take out a factor of x plus 1. Remember how these are always the opposite of what the factors were? But this is easy to factor now, and I can solve this. I'm going to set it equal to 0. The reason it's easy is I can see I can use grouping. I'm going to take an x squared out, and I'm left with x plus 1. I can factor out a 4, and I'm left with x plus 1. We've seen this pattern before. I've got two terms now. Here's one of my terms. Here's the other one. What factor do those two have in common? Well, they've got an x plus 1. So if I take out an x plus 1 from this, I'm left with an x squared. If I take out an x plus 1 from this, I'm left with an x squared plus 4. Or just plus 4, rather. So now these are my other two factors. So I have to solve. I've got x plus 1 equals 0, or x squared plus 4 equals 0. This is easy to solve. What plus 1 is 0? Well, that's negative 1, right? This one, I'm going to have to do x squared equals negative 4. Take the square root of both sides. X equals plus or minus. The square root of negative 4 is 2i. So my other two zeros are going to be 2i and negative 2i. And let's see if this all works out. Based on Descartes' rule of signs, I should have one positive real. 2 is a positive number, right? I can have either 2 or 0 negative reals. Well, here's a negative real, and here's a negative real. So those are those two, and then I can have two imaginaries. And these are all the zeros for that problem. Okay? So that's what you're going to have to be able to do. See, negative 1 is a solution twice. And that's fine. That happens. All right. Let's look at this last one. We're going backwards now. Write a polynomial function f of least degree that has rational coefficients, a leading coefficient of 1, and the given zeros. So 0 is a 0. So what was the factor then? Well, it had to be x. So I know I've got x. 8 is a 0. What was the factor? X minus 8. Now, that's what I know so far with these two. I'm just going to work with these two to start. I'm going to multiply them out. I get x squared minus 8x. Okay? We have learned that if 3 minus I, that's a solution, then I know the conjugate of this imaginary solution must also be a solution. So if 3 minus I is a solution, so is 3 plus I. Now, here's something that's very helpful. Every time I know two solutions, I know that the factor that those came from have to be x squared minus the sum of the solutions times x plus the product. Okay, I want to come down here for a minute and just explain that. This is just this formula. So let's say that 2 and 6 are the solutions. Okay, what's the sum of 2 and 6? 8. What's the product? That means multiply. 12, right? So that means that the quadratic that would have these solutions must be x squared minus the sum x plus the product 12. That if we started with this, we will get solutions of 2 and 6. Let's show that. I factor this, right? I need x and x, numbers that multiply to be 12 and add to be 8, or 6 and 2, minus and minus. What minus 6 is 0? 6. What minus, see how that works? It'll work every single time. If you have these two solutions of x equals 2 and x equals 6, then we can just find the sum and the product, and we can quickly come up with that quadratic. That's how I like to do this problem. I'm going to find the sum of these two. If I add these two together, 3 minus I plus 3 plus I, what is that? 6, right? Now I'm going to find the product. Now multiplying these two is a little tougher. I have to FOIL. I have to do the first times the first is 9. The outers give me plus 3I. The inners give me minus 3I. The last times the last gives me minus I squared. Anytime we multiply a binomial, we have to do that process. Everything has to get distributed. So now I'm going to find this product. Positive 3i minus 3i cancels. 9 minus, what's I squared? Negative 1, right? 10. So here's the sum and here's the product. So based on this rule, the quadratic that would have these solutions would have to be x squared minus the sum x plus the product. That would be the quadratic that would give me those two solutions. But we want the polynomial function that has this solution, plus these solutions. So now I have to do the complicated part. I'm now going to multiply x squared minus 8x. See, that gave me the two solutions of 0 and 8. I got to multiply that by this. That's going to give me my polynomial function, f, that has those zeros. All right, so I'm going to multiply it out. I got to do this times this, x to the 4th, minus 6x cubed, plus 10x squared. You should pause the video and try this on your own. Minus 8x cubed, plus 48x squared, minus 80x. Okay, so combining all of that, my function's going to be x to the 4th minus 14x cubed plus 58x squared minus 80x. And that should be the function that has those solutions of 0, 8, 3 minus I, and 3 plus I. I want to show you some really cool things on your calculator. Let's see if this, darn. Let me see if I can find my other calculator that has a quadratic formula. There we go. Okay. This is going to be awesome. So I'm going to go to y equals. I'm going to put in my function that I just found. X raised to the 4th. This is just kind of like bonus learning. If you don't want to see it, you can turn off the video, but I think it's so cool. Minus 80x. Okay, so I've got this in here. This is what we think the solution is, and I hope I didn't make a mistake. I don't think I did. All right, so then I'm going to do my zoom 6. I'm going to look at the graph. I should see my 0 come through here at 0 and 8. That looks good. Hopefully it'll hit right there at 8. Come on. Yay. Okay, now we're going to look at our table. Okay, I can see that I have my 0 at 0, which I'm supposed to, and I've got my 1 at 8, right? Okay, now let's come back here and let's check this real quick. Here's what I'm going to do. I'm going to go to my mode. I'm going to make sure that I have this in my A plus BI so it can tell me solutions that are going to be imaginary. I'm just going to double check this and make sure it has solutions of 3 minus I and 3 plus I. I'm telling you guys, with all we have these days, like, gosh, there's so much you can use to check your work. It's awesome. I'm going to go to program. I'm going to go to my quadratic formula, and my coefficients 1, -6, and 10. There we go. That has solutions of 3 plus I, 3 minus I. That's why we put that quadratic formula in here, because it can help us. So now I'm positive that this is perfect and we've got it all right, correct. Okay? All right, guys. Remember, anytime you need questions, feel free to email me and I will be happy to help you. Or, if I have you in class, I'll be happy to help you then. All right. Have a great day.